In this example, we are going to find the area kind of bounded by these different situations, these different equations and things like that. Very much more, very helpful if we had some sort of a visual. So I threw this into Desmos and let this thing all graph itself. If not, throw it in a calculator. We need a visual though. So we're going to be finding the area bounded by y equals e to the x. So y equals e to the x is going to be this red one. Y equals e to the negative 2x is an exponential decay, which is the blue one. And then y equals the natural log of 4 is just a value. So it's just a vertical line at that value, which is the natural log of 4 is that value right there. All right, so what we need to figure out is our bounds because we're finding this area between these things. So we're going to be going from essentially a 0 to a natural log of 4. Because I know that that's happening because that's the vertical line, the green vertical line. So we're going to be going 0 to the natural log of 4. Okay. And then we're going to take the top equation minus the bottom equation. So the top equation is your e to the x. And then this is our exponential decay, which is e to the negative 2x. So top equation minus bottom equation. And this is the math we're about to do. So if I do the antiderivative of e to the x, it is e to the x minus. Now this one's going to be a little bit more complicated. I need to do a little u substitution on that. And so I have, let me just kind of independently do this one. Let me keep the sign out of here and see what happens. So I'm going to do the antiderivative of, I'm going to pull the negative e to the negative 2x dx. I would do a u substitution of negative 2x. And then my du would be negative 2 dx. And that would be negative 1/2 du equals dx. So then I would have a negative 1/2 antiderivative of e to the u du. And that would become e to the u with a positive 1/2 in the front. So that's my antiderivative. So it turned positive because I brought that negative with the work that I did. It turned positive 1/2. And now instead of u, I can put my negative 2x back in. All right, and we're going to go from 0 to the natural log of 4. All right, so let's start plugging things in. We have e to the natural log of 4 plus 1/2 e to the negative 2 times the natural log of 4. That's plugging in the first piece minus e to the 0 plus 1/2 e to the negative 2 times 0. That's my other value. Okay, so e to the natural log of 4 is just becomes 4. The base of the log matches the base of the exponent. That all just simplifies and turns into 4. And then this almost has this feel to it, but that negative 2, here's kind of the little extra work we have to do on that. This e to the negative 2 natural log of 4, we got to pull that back as an exponent, which makes it e to the natural log of 4 to the negative 2. And 4 to the negative 2, e to the 4 to the negative 2 is 1/16 because you're still squaring the 4, but you're putting it into the denominator. And so now we have this exact same situation where this base matches, and so that's just a 1/16. Right, so that value becomes 1/16 times the 1/2. So 1/2 times 1/16. So that piece minus e to the 0 is 1. This is going to be a 1 times 1/2. All right, let's keep doing some math here. So this is going to be 4 plus 1 over 32. All right, and then minus 1 plus a half. So that is 3 halves. All right, and then the last part is putting all this stuff together. So I need this denominator to be 32. I need this to be 32. So I'll multiply it by 16. Multiply the 4 times 32. So we are looking at 128 over 32 plus a 1 over 32 minus a 48 over 32. And if you add all the tops together, you're going to get an 81 over 32. And that would be this area between those two curves.